Colormetric Laboratories Incorporated presents A Guide to Dermal Exposure Reduction. The goal of this video is to educate workers about the skin exposure potential to chemicals such as amines and isocyanates, which are commonly used in the manufacturing of polyurethane products. Being able to identify areas where contaminations may occur is critical to reducing dermal exposures to these chemicals. In the United States in 2010, dermatitis was prevalent among approximately 15 million workers, or about 10% of the labor force. Interestingly, of all the chemicals that are regulated, about 60% of them carry some kind of skin notation. Though sometimes it goes unnoticed, preventing skin contact with these chemicals is in the best interest of your employees and business in order to prevent any subsequent illnesses. In the case of isocyanates, independent studies have shown that from dermal exposure alone, these chemicals have the ability to induce pulmonary sensitization, producing asthma-like symptoms to those exposed. In the polyurethane industry, products are typically comprised of two main components, an A side, which contains the isocyanate, and a B side, which has a polyol. Depending on the desired properties of the final product, additives such as surfactants, flame retardants, and pigments can also be added to the system. In this case, we have two drums of isocyanate resins on the right, each containing different additives to achieve the desired properties, and on the left are containers of mocha, an aromatic amine which acts as a cross-linker between the isocyanate and polyol. In this type of system, the exposure potential is reduced to a few areas since most of the operation is automated. Areas to check for contaminations include the hose endings going into the drums, the floor beneath transfer hoses in case of any cracks or leaks in the line, and the tops of drums in case of spilling or splashing during removal of the lines. Here is one of the isocyanate containing drums shown previously. After a worker finished pouring an additive into the drum, we decided to test the top surface for any contaminations that arose from the removal of the hose or the transfer materials. Looking for isocyanate contamination, we lightly spray the test surface with our developing solution near the opening of the drum. Wait approximately 30 seconds, and then wipe the surface with an aromatic isocyanate surface swipe. In this case, the color reaction started almost immediately due to a contamination on top of the drum as a result of the removal of the hose. Here's just another example of a contaminated drum head. What we see here is an isocyanate resin that has cured and hardened over time. While cured resin doesn't pose a big risk for skin exposure, it is best to promptly clean up any contamination so that other workers don't inadvertently place their hands or tools on resin that isn't fully cured or is even still liquid. Right around the corner from these drums is the mixing head. With most of the process being automated, contaminations in this area would be limited to any splashing while the mixture is being poured into containers and any subsequent dripping from the mixing head itself. Keeping the mixing head and the surrounding area clean and clear of any debris will help reduce the spread of contaminants in this area. For reduced batches or customized products, a smaller scale system such as this one may be used. The vacuum hose shown on the right is manually placed into a container of mocha pellets by the worker. Once melted at the top of the machine, the liquid mocha is dispensed directly into containers below. Just like with the mixing head seen previously, splashing and dripping would be the most common ways that contamination is spread. The white dots in this picture are mocha that has splashed onto the nearby surfaces. To test, we first lightly spray the area with the aromatic amine cleaning developing solution. You wait about 30 seconds, and then an aromatic amine surface swipe was run across the surface, and the color was allowed to develop for about 5 minutes. After half a minute, the red color was already developing, as expected with a noticeable contamination such as this. Allowing the swipe pads to fully develop, a definitive mocha presence is shown, with a deep red color on the swipe. Being a small-scale production, any pigment or other additive would be weighed out on a scale and manually mixed together with the mocha. The exposure potential to the melted mocha or isocyanate used during mixing is extremely high, and special care should be taken to reduce and eliminate any splashing or spilling that could occur during mixing. As seen here, splashes can be seen on virtually every part of the scale. While the contamination consists mostly of various pigments, special care should be taken while handling any chemical in order to reduce the potential for skin exposure, prevent the spread of contamination, and to keep the work area clean in general. Sometimes workers can unknowingly transfer contaminations from their personal protective equipment to other items, such as tools and writing utensils. The benchtop shown here is an area where melted mocha, isocyanate resins, and other additives are mixed together using the tool on the right. If this surface gets splashed or spilled on during mixing, the contamination could spread to other tools or any writing utensil that the worker will subsequently use. We tested the benchtop for isocyanates, as we saw what may have been a resin on the surface. Using the developing solution, we once again lightly sprayed the area and then waited approximately 30 seconds before wiping with an aromatic isocyanate surface wipe. Allowing the color to develop over the course of about 5 minutes, a minor contamination was seen on the swipe pad. This guide to dermal exposure reduction is intended to increase employee awareness of the skin exposure potential to chemicals such as amines and isocyanates, commonly used in the production of polyurethane products. Using CLI surface wipes, workers can test process areas for contamination, verify the need for personal protective equipment, and then decontaminate the area. Regular swipe testing of certain areas throughout the facility can help control the spread of chemical contamination. The swipe results can even be used as a basis for safety training by visually demonstrating the need to follow safety procedures. Some common surfaces to test would include tools, finished products, work surfaces, production equipment controls, safety glasses, or any writing utensils. For more information about CLI, this video, or any of our products, please visit our website at clilabs.com or feel free to give us a call at 847-803-3737.